Okay, class, welcome back. Today we're talking about hypothesis testing in lecture 20. So today we are doing the big league stuff, the real stats, closer to what people actually do. Um, and the idea is that we're going to use confidence intervals to really do what stats people do. So we're going to make use of them. We're not just going to create confidence intervals. And the idea is that we're going to draw conclusions, whatever that means. So this lecture will be very theory heavy, but then tomorrow will be example based, and you'll see it won't be as bad as today. Today will make it seem a little bit more difficult than it is. Today is about building up the words to use and stuff like that. Okay, so let's get to it. So the first thing to learn about is what a hypothesis is. So you've probably heard this word in science classes, but in this class, it's maybe a bit more specific. It's a statement that, a statement about a characteristic of a population. So for us, a characteristic is always just going to be a parameter, meaning a numerical value associated to a population. So in this class, we've only done two parameters, it's either proportions or mean. So that's the nice part. We're only going to be talking about two types of numbers, either a proportion of something or an average of something. And so let's see some examples. So for example, a statement like this: the proportion of Americans who are satisfied with their, personal lives is 80%. So this is a statement because the idea of a statement is it's just something that's true or false. So this is either right or wrong, but in any case, it's about a population. So here the population is Americans, and the characteristic is the parameter of proportion, and the statement I'm making about it is that it's 80%. So this is a statement about a proportion, and therefore it is a hypothesis. Okay, so that's what a hypothesis is. That's an example of a hypothesis. Another one could be very similar. I could write down the exact same statement almost. So the proportion of Americans who are satisfied, I'm just going to change it a little bit, with their personal lives is below, I could say below 80%. That's a different hypothesis. I'm making a different claim, a different statement about this, about a population proportion still in both cases. And in fact, I could also change below to above, and I can get a third statement, a third hypothesis. So these are all three different hypotheses you could write about the same population proportion and the same number, 80%. Or you could also change it to not. So I could say the proportion of Americans who are satisfied with their personal lives is not 80%. That is another hypothesis. It's another, again, statement about a characteristic of a population. In this case, all of these are all about proportion. So then you have statements like these are hypotheses. And then what researchers do, how do you spell research? Researchers. So what you do is you do hypothesis testing. And so the idea is that you do these on these kinds of hypotheses. And that's what we're going to learn about. And then the basic idea is that you just check their validity. Whatever that means, it's a bit vague right now. And the way we do it is we use all the stats we've learned from samples that you get. So you make a hypothesis like this, maybe. You say, I claim that the proportion of Americans who are satisfied with their personal lives is below 80%. And then you check that validity using something called hypothesis testing. And hypothesis testing just uses all the stats we've learned. That's the basic premises. Okay, so here are the steps to hypothesis testing. So once we get into example, we'll break down and do even more specific steps than these. But this is sort of the more general steps. So the first thing is you have to, first of all, make a hypothesis about a population. So just using another example here, I could say something like the proportion of Whittier College students that like, I don't know, soccer is below 40%. So this is a hypothesis about the population being Whittier College students in this situation. And then I want to know if it's valid or not. I want to think about, like, does this hypothesis make sense? So what I can then do is I can collect sample data, and it's got to be done randomly to really be correct, to get a statistic, meaning like a sample proportion. So you see we're claiming something about the actual proportion being below 40%. And so then I am getting a sample proportion. If I was talking about proportions, if I was talking about means, I would get a sample mean instead. So then now we use all the math that we just learned. And so what we do next is we analyze. Is that how you spell analyze? That doesn't look right. There's an extra A here, that's why. Okay, analyze statistic that we get to determine so it's a bit tricky. So we're not going to determine if the hypothesis is true. We're going to determine if it's, the better word is plausible. So we're never going to say, yes, this is true. What I said earlier is true. And that's never going to happen. It's a bit tricky. We'll get into it later, but we're going to determine if it's plausible is a better way to say it. And then the whole point of what we just learned is confidence intervals. And what we're really doing is we're going to use those confidence intervals. But we're not really going to say the phrase confidence interval while we do it, but that's what we're secretly using. And then some other math too will come into it. Okay, so that's the big picture idea. Now to get into the more detailed stuff, we need to introduce some language that people use. So what we do is, in a hypothesis test, the kinds that we're going to learn in this class, there are always two hypotheses. Okay, there's always two. The first one is called the null hypothesis. Now, again, as we've seen a lot in this class, stats people love to create new names to make things seem extra difficult. So null hypothesis sounds very fancy. So I know, and it sounds very difficult. So the null hypothesis, first of all, what we do is we write it a certain way before we worry about what it is. It's written as capital H sub 0, subscript 0, but people read it as H naught. That's how people read this. And what it is, it's the statement. So it's going to be a hypothesis because it is a type of hypothesis, and therefore it's a statement about a population characteristic. So what statement is it? It's always the statement about the hypothesis to be tested. So it sounds a bit confusing the way it's said here. And the way to really remember what the null hypothesis is it's really just the statement that you assume is true. So this statement is always assumed to be true. So what the null hypothesis really is it's a statement that you're assuming is true about the world, or true about your proportion, that you just are taking for granted, and you're testing if it is plausible that it's actually true. And that's what this fancier thing is saying up here. So it's a statement about the hypothesis to be tested because it's the statement that you're assuming is already true about your proportion, and you're testing to see if it actually is true. Okay, once we do more examples, it won't feel so confusing. So the statement is always assumed to be true, and then should be a comma there. What we are trying to do, the researcher, we are looking for evidence against it, or to contradict it. So what you should really sort of think about is, in the court system, people are innocent until proven guilty. This is one way to think about the null hypothesis. So in the court system, the null hypothesis is innocence. So you are assumed in a trial to be innocent. And then the prosecutor is looking for evidence to contradict that possibility. And that's the idea behind null hypotheses too. So the null hypothesis is what you assume to be true about reality, and then you try to find evidence to show that that's not actually the reality. And then what people do is they write this other hypothesis. So this is the first hypothesis. So I said there's always two. So the first one. So the other one is cleverly named the alternative hypothesis. And so this is like what you're trying to show is actually true instead. So it's sort of like proving someone is guilty. but it also comes with its own fancy notation. So it's written as H, capital H, subscript 1. So it's just read as the alternate hypothesis, I guess. And what it is just the opposite of H naught, of the null hypothesis. So it's really the statement that H0, H naught is false. So in practice and examples, we'll see how to always write H1 based on the question. So it's not so hard to figure out in practice, we'll see. But then the point is, we then look for evidence to support it. So you're always trying to show that H1 is true. But you're living in a world where you're assuming H0 is true. So in a trial, you're assuming that the defendant is innocent. You're pretending it's true automatically. And then you're trying to show that that can't be the case, that in fact that person is guilty with evidence. Okay, so let's do some examples to see how to identify these lingo-heavy things. Okay, so a question like this is very common. So according to a Gallup poll, very fancy poll from way back 2008, very old textbook, getting this from, 80% of Americans felt satisfied with their personal lives. And so now you, the researcher, if you want to imagine that you are this researcher, so a researcher wonders if that has changed today. So this gives us a situation in which we can write down a null hypothesis for this researcher and an alternative hypothesis for this researcher. So that's all we're going to answer. What is the null hypothesis for the researcher? And what's the alternative hypothesis? AKA, what is H0 in this situation and what's H1? Okay, so it's not so complicated as it seems above. So the null hypothesis is what is sort of assumed to already be true about the world. So what's going on is that the researcher is wondering if things have changed since 2008, where 80% was apparently the correct proportion of the population that had this property. So to answer what the null hypothesis is, it's just going to be 80% or 0.8. Okay, but how can we write this out in a nice way to think about it? So since the researcher is wondering if the proportion, so again, we're talking about proportions in this problem. So I'm going to call it P, because it's a proportion of the population that they're studying, which is Americans in this problem. They're wondering if that has changed they're assuming to begin with that 0.8 was originally correct. Because in order to wonder if it's changed, that means you must be pretending that 80% is already correct. hope that makes sense. You can only wonder if it's changed if first you accept that 0.8 was correct in the first place. So that's the idea. So they're assuming that P equals 0.8 originally. So in this situation, the assumed true statement is that P, the proportion, is 0.80. So that's our null hypothesis. But we write it in a much quicker way, just because math people like to hide all the information. So all we write is this, H0 colon, and then what the null hypothesis is, which is that P equals 0.80. But really this is saying a whole bunch more. This is saying all this stuff up here. This is saying that the researcher is assuming that the proportion of Americans that are satisfied with their personal lives is 80% already. So they're assuming that, and that's why I write this. But you don't have to write all that every time. You just have to write what I just wrote. But what it really means is all this. The null hypothesis. It's good to write out things in words, though, because they help you see what's really going on. To mean that, so this really means that the null hypothesis is that the population proportion is 0.80. That's what this is really saying in a very quick way. So then what's the alternative hypothesis? Well, the alternative hypothesis is just wondering if that proportion has changed. But how do I say changed or different from in a more mathy way? That's what we have to do. So since the researcher wants to see if it's different now, if the proportion, I guess I should say that, then the alternative hypothesis, I'm going to shortcut right now because it's taking too long. The alt hypothesis is that, well, what does it mean to be different from 0.80? Well, in a mathy term, that means it's not equal to 0.80. So all we got to do to write our alternative hypothesis is H1 colon, and then we just write what I just wrote. P is not 0.80. So again, this really means a lot more. It means that a whole phrase, it really means that the alternative hypothesis for the researcher is that P is not 0.80 anymore. The population proportion is not 0.80. Okay, so I didn't use the letter up there, but same thing. Okay, and that's it. So let's try doing that for a couple more examples. So write down the null and alternative hypothesis for in each situation. Let's see if we could just do that. So we're not doing any hypothesis testing yet today. We're just sort of getting the idea down. And then we're just saying the null and alternative hypothesis, which is really the first step to doing hypothesis testing. Okay, so I'm just going to pop this question in because it's very long. So let me just do that. Okay, so here I popped in the big old example. So a pharma company develops a new antibiotic for children. 2% of children taking competing antibiotics experience headaches as a side effect. An FDA researcher wants to know if the percentage of children taking the new antibiotic who experience headaches as a side effect is more than 2%. All right, so a lot to unpack here, big giant word problem. But all we're trying to do is write down the null hypothesis and the alternative hypothesis. So we're halfway done there. That just starts it. So what is this researcher assuming is the typical percentage or proportion, because percents are proportions, what is the typical proportion of children that usually get headaches with this type of medicine, competing ones though? Well, they're assuming that 2% is like the standard truth. So that is going to immediately tell us that the null hypothesis is that the proportion of children that get headaches as a side effect with this kind of antibiotic is going to be 2%. So now, what's the alternative that they are asking is happening, if it's happening with this new antibiotic? Well, they are trying to see if this antibiotic, not just that the percentage of children that get headaches is different than 2%, but if it's more than 2%, more specifically. So this is going to tell us that the alternative hypothesis, so what the researcher is checking to see if this happens instead, is that if the proportion is bigger than, which we write with this symbol, greater than, or you could think of it as more than, they want to check if that's bigger than 2%. So they want to check that. And that tells us our alternative hypothesis. So, whoops, not equals, should be greater than. So all that work, writing this big old paragraph, and really, it's just, this is all we're doing, is writing this down. We're just extracting this information. So then, just as a little aside, I can change and get some more new things. So we can change the phrase more than to a couple different things. If I changed it to less than, then my null hypothesis and my alternative hypothesis would change a little. Well, the null won't change at all because I'm still pretending that 2% is like the truth, it's the standard. But now I'm checking if my proportion is below 2%, so it's a less than symbol instead. But then I could also change the phrase more than to not, and then I'm sort of like the other one, where now the researcher is still pretending that 2% is correct, so that again the null hypothesis will not change, but the alternative is not that it's bigger or less than, it's just that it's not 0.02. So it becomes a non-equal sign. So there's 3 different answers depending on really just these words right here. More than. Okay, so let me write down another example. Let me pop it in again real quick. Okay, so here is the next example. The Blue Book value of a used 3-year-old Chevy Corvette ZR1 is $86,012. The seller wonders if the mean price in his area is different. So in this problem, the researcher is just a seller wondering if the mean is different from this number here, 86,012. So in this situation, the null and the alternative hypothesis are no longer talking about proportions. Instead, we're talking about means. So we're looking at the average. So what is this researcher, what is this seller assuming is the actual average price, and what is the seller trying to see if it's different around themselves. Well, the seller is assuming that the Kelley Blue Book value is the correct price, the correct mean price. So what we're doing is we're using this number, and we're going to assume that this is the actual mean. So our null hypothesis is to assume that the mean is 8,612. Now the symbol for mean is not the letter P, it's the Greek letter mu. So this is how our null hypothesis will look. But really what we're doing is we're assuming the mean is this much money. And the researcher is wondering, okay, this is the standard average price. Is it different in their area? So they want to test if the mean is different. So that's the key word there. And that's really saying not equal to 8612, because they're not specifying whether they think it's more or less than that amount. So this is the alternative hypothesis in this situation. So again, if I just change the word different to more or to less, then that's just going to change the alternative hypothesis into these two different options. So the researcher in this situation is not specifying whether they think it's more or less, just whether they want to see if it's different at all. Okay, so now for the big picture idea, and then tomorrow we will do actual examples of this big picture idea. This is how it's going to work. So we work, or the researcher works, assuming H0 is true. That's the idea. You assume that H0 is the true actual answer of the universe. And then what we do, remember how we're supposed to get this sample. If we get a sample just crazy enough, so maybe being very loose with language here, crazy enough, what we actually do is we stop and think, wait a minute, if this is the true answer, so for example, up here, if it was true that the average price was 8,086.12, and then I got some crazy sample, maybe the average price of my sample was like $1 million or something instead. That might make you question, how could this possibly be true? How could this be true if I got a sample and my average mean of that sample was $1 million? How could that be? How could this average be true? And that's the whole idea. So then what we say when this happens, if it is crazy enough, we say, actually, wait a minute. It couldn't possibly be true. We were lied to. It couldn't possibly have been true, our null hypothesis. And then what people do is they reject it. They always, you'll see this phrasing a lot. We reject it. And so what this means is that in a hypothesis test, so in all these problems that we're actually going to do, there are only two outcomes. That we can do. So in a hypothesis test, I guess I should say that. In a hypothesis test, there are only two outcomes really that you can do. You can say, one is what I just described. You can reject H0. So what this is saying is that you've got like such a crazy sample that's so far from what the truth of the universe is supposedly going to be that you deny the truth of the universe, so you reject the null hypothesis. So you can either reject it or you can never accept it. The only other thing you can do is you could not reject it. And really that's just saying that you didn't get a crazy sample. So maybe you got a sample and of these Chevy Corvettes and your sample mean was 86,013. So if you got that as your sample mean, would that make you question if this is true? No, it's super close. Maybe that's probably very likely to happen. So you wouldn't question whether this was true, but at the same time, you wouldn't get to automatically say this is true just because your sample was pretty close to it. That's the idea. And so I have to write this in all caps. This is not the same. Never accept the null hypothesis. So this is not the same as accepting the null hypothesis. So if I got a sample that was 86,013, I'm not going to run and say, aha, I know this is true. This must be true because my sample was so close to it. No, I'm not going to say that because all I did was get a sample that supports something that I was already pretending was true in the first place. I can't prove something true if I'm already pretending it's true. That's the idea. So I can never accept the null hypothesis. The best I can do is not reject it because I got something that wasn't that crazy. That's the big picture idea. So yeah, so we cannot know for sure if H0 is correct just by getting a supporting sample, a sample that's perfectly in line with whatever H0 is saying is true. So we never accept. We just don't reject it. It's a bit subtle, but it's different. It's very much like saying that someone is not guilty versus saying that they're innocent. So subtle difference there. And the mathy explanation is very cool and I like it, so I'm going to say it. But what's really going on here is this is because you cannot prove something is true if you start by assuming it's true, which is what we're doing. So you can't prove that the sky is blue by assuming it's already blue. That just doesn't make any sense. And that's what's going up here, up here. So you can't prove your null hypothesis is true. All you can say is it's not wrong. Like, I don't know that it's wrong, but that doesn't mean it's true. You can, however, this is the interesting thing, you can, however, prove something is wrong by doing this, by first assuming, this is the interesting thing, assuming it is true and then finding evidence that something like impossible or crazy happens as a result of it being true. And then together, this means, well, it couldn't possibly be true. And that's really the idea, the mathy idea behind how these things work. Okay, so next time we'll do examples. And I know this lecture is very theory heavy and without many examples, but we will break it down step by step. It won't be so bad, I hope. Okay, so see you next time.